Hello, grade nines. What do you think of my new digs? I took all the whiteboard things from the classroom and I just pinned them all onto my wall here, so hopefully this will work as a whiteboard. I didn't realize how expensive whiteboards are to purchase, so I decided to go for this route instead. I hope it's okay. It's pretty fresh right now. As we do a few more lessons, you'll notice some of the seams will start to get a little bit darker. I'll do my best to keep it clean, but kind of working with what we got here, so that might not always be feasible. So I apologize if it's difficult to look at, but we're working with what we got. Today we're moving on. We're still in linear equations, linear relationships, or in short, to linear relations. And last time we looked at an equation. So you don't have to write this part down, but our equation always started off with a y. And y was equal to something. For example, 3x plus 1. And I think we did a couple of examples, like the hockey stick example and stuff like that. This is a situation where we have two variables. One of them is on one side of our equation. The other one is on the other side of our equation. So it's useful because it's isolating one of the variables for us, which is really good. We always know what y is, as long as we have a number to plug into x. What we're going to be looking at now is what happens if both of those variables are on the exact same side. Okay, and we're going to work with an example to figure that part out. And if you don't have it already, I put the title up. This is going to be called another form of a linear equation. Straight away, we'll jump into an example. I'm going to be in your way for a second, but I'll get out of the way so you can write it down. The example we're going to work with is, we're going to say, or let's say we have two integers. We'll call them x and y. You can use any two letters you wanted, but x and y is typically what we use in math. So we have two integers, x and y, and when we add these two integers together, they're always going to equal 3. The important thing is integers and 3. Integers means it can be any positive or negative number, excluding, repeating decimals and stuff like that. So just some nice-ish numbers can be positive or negative. When we add them together, we end up getting 3. And what we learned last time is a nice way to figure this out is to make something called a table of values. So that's what I want to try out. So table of values is really simple to make. Whenever we're dealing with a relationship, we can do this. You have one value for x. Whatever x is, we can figure out what y is, and then vice versa. So for example, let's say that x was, and I'm going to pick some specific numbers here, but let's say that x was equal to -4. And since we know that x and y together are going to give us 3, we should know what we can add to -4 to give us 3. So what can we add to -4? Well, if I add +4, I'm at 0. And if I want +3, I have to add 7 in total, so 3 more than that. And if we want to test it, we can. -4 plus 7 is equal to 3. So we're on the right track. Let's try another number. -2. Well, if I want 0, all I have to do is add +2 to that. And if I want +3, I have to add another 3. So +2, +3 is 5. Here's another one. It's not really that tricky, but what if I gave you y instead? What if I said that y was equal to 3? Well, what plus 3 equals 3? And the only option we have is 0. You don't have to test it, but just to be thorough, I'm writing it down. We're going to do one more. That's going to be, let's do +2 for x. +2 plus what is going to give us 3? How about 2 plus 1? 2 plus 1 equals 3. I want to do one more example. Just let's say we went up to 4 for x. What can I add to 4 to give me a +3? Well, +3 is smaller than +4. So the only thing I can add is a negative number. 4 plus -1 is equal to 3. And if you remember rational numbers, plus and a minus together just give you a minus. So 4 minus 1 is equal to 3. And essentially what we've done here is we have tested out the equation x plus y is equal to 3. All of this is just telling us that x plus y is equal to 3. And that's the equation that we're working with. Now in math, whenever we have an equation, we can graph it and we get a lot of information from that. So we're going to use this information here, a table of values, and remember we're going to plot it kind of like Battleship onto a graph, and we can see what the graph of x plus y equals 3 looks like. So I'm going to start over here with -4 on my x, so I got to find on my x-axis, which is the one that goes left to right, -4 is over here, and y is +7, so I have to move up 7 spots. So there's 2, 4, 6, and 7 is going to be somewhere over here. And I'm going to do that with every single one of the points here. And you'll notice I just sketched this freehand. Like I didn't use a ruler or anything, and it's a good habit to use a ruler or some straight edge to draw your graphs. In your notes, I'd recommend it. Just get into a good habit. But if you're just testing it out, if you're not doing it for a test, or if you're not doing it to have neat notes, like you're just doing some practice, you can do it freehand. You'll realize that if you have a linear relationship, you should still get a relatively straight line, provided you're drawing it somewhat neat. Because we're dealing with integers as well, we can't connect the dots, but we can use a dotted line, which is what we talked about last time. Like that, it does happen to be a straight-ish line. It is a straight line, it's just the drawing, because freehand makes it less obvious.